Okay, Bismillahirrahmanirrahim. Assalamualaikum and a very good morning. So thank you to all of you who have joined this online class. So we will continue our dynamics class. In the previous class, which is last week, we talked about rotation, about a fixed axis. Okay, so if you can see the screen that I have shared, you can see that when the body is rotating, in this case, the rotation is anti-clockwise in this direction. Okay, so we have theta there. So basically, this is just to recap what we have learned previously in the previous class. So theta will be called as the angular position. Okay, angular position with the unit of radian. Okay, with the unit of radian. I have shown in the class how to convert from degree to radian. And then this will be equivalent or similar to for linear motion. We have S or R lah. S is called a displacement. Okay, displacement. Right, so this is for linear motion. Linear motion, which is in straight line lah. Linear motion. And currently we are talking about rotation. So this will be rotation motion lah. Rotation about a fixed axis. Okay, and then if we differentiate the angle, which is theta, over time, so we do d theta over dt to see how much the change of angle happens with respect to time, then this will be equivalent to what we call as omega. Okay, omega is a Greek word. Okay, and this is called the angular velocity. Okay, angular velocity, and the unit will be radian per second lah, radian per second. Okay, because we differentiate the angular position, radian divided by time, so we get the angular velocity omega. The unit is radian per second. And similarly, for linear motion, we have the velocity called or known as v lah. V is the velocity, which is ds over dt. Okay, we differentiate the displacement over time, and this is what we get, which is the velocity or linear velocity lah. Normally, we just write it as velocity. You understood, or people understood it as linear velocity. Okay, and the last one is we can also differentiate the angular velocity, which is omega, over time. So you do d omega over dt, which will give us alpha. Okay, this is another Greek word, and alpha is known as angular acceleration. Okay, acceleration. All right, so if we differentiate angular velocity, which is already radian per second, divided by another unit of time, so the unit will be radian per second square. Okay, this is the angular acceleration lah. And similarly, for linear motion, we have a, which is acceleration, and this is given as the differentiation of dv over dt. So this is acceleration or linear acceleration. Okay, so this is what we have learned in the previous class. And also, we have learned an equation in the previous class. When we talk about rotation, we have one equation which is called V is equal to omega times R. Okay, V is the velocity, omega is the angular velocity, and R is the distance from one point to another. I will explain further in the next slide. So this is for scalar quantity. Okay, this is scalar quantity, and most of the time the calculation in this chapter will involve vector calculation. So for vector, the equation will become v vector, or let's say we call it as uh, v of a point lah. Later we will use the notation VA, VB, and so on, is equal to omega, another vector, and then vector cross product. X there is the cross product of R, which is the position vector. Position vector we have learned before, and how to calculate position vector. So this will be the vector punya vector equation lah. So we have two similar equation. One is in the form of scalar, the other one is in the form of vector. Okay, so let's look at how the equation V equals to omega R was derived. Okay, so basically what we want to know now is how the equation V is equal to omega times R is derived lah. Okay, so let's look at how this is derived, just for your information. Okay, so here you can see there is a point. I'm going to zoom in. Okay, there is a point P, and we have the center point of O. So the first thing that we can do here is to draw the position vector. Okay, remember the position vector, it starts from the origin. So it starts from the origin pointing to point P. So this will be uh, R RP slash O. Okay, what you can write here is RP slash O. Okay, and then let's say that this whole object is rotating in anti-clockwise direction. Okay, in anti-clockwise direction. So in which direction is the velocity of point P will be pointing? Okay, velocity of point P, I have explained also in the previous class that it will be pointing, it will always be tangent to the path. So if you notice here, this will be the path of point P moving around the center point or the origin O. Okay, point P will travel in a circle like this. Okay, this is how point P will travel. And at this particular point, tangent to the path will be in this direction. Okay, because the rotation is anti-clockwise. So we can then draw the velocity of point P pointing upwards. Okay. Okay, like that. So this will be VP, the velocity of point P, pointing upwards. Okay, the velocity is always tangent to the path, or the easiest way is that you can if you are confused with how to draw tangent, then you always take the velocity of point P 90 degrees to the position vector. Okay, the velocity is always 90 degrees to the position vector. All right. So in this case, if we take now, for example, point P, let's say point P now has traveled to here. Okay, point P has traveled to here. Let's call this another point P, there. Okay, so in which direction, or let's draw first the position vector, the new position vector. So it will be, let me zoom in. Okay, it will be like this. This will be the position vector of point P, which is still the same. This is RP slash O, still the same. Now we can also draw the velocity of point P. So the velocity will be 90 degrees to the position vector. So which will be in this direction, right? So this will be VP, the new VP. Okay. So this will go on as point P is rotating about point O. Okay. So here is basically the alpha. Sorry, the theta. Okay, here is the theta lah. Okay. All right. So if you remember in mathematics, you have learned before, um, we have something called sector. If I'm not mistaken, it is called sector. So when you have uh, something like this, okay, and you want to calculate this. This is called S. I think this is called S. Okay, and you have the angle theta, and you have here the value of R. Okay, R is the radius lah. Okay, imagine that this is a circle. So you take a part of the circle, like a slice of pizza, and you want to calculate what is the value of S. This is called sector, and the equation here, S will be equal to R times theta. So this is the equation lah, R times theta. Okay. So coming back to our point P here, the velocity of point P. So VP, so basically we have the equation V is equal to ds over dt. This is the basic kinematics equation lah, for linear motion. And we know that S here is equal to R times theta. So this equation, we can rearrange this. So this is basically VP lah. VP is ds over dt. Okay, S is basically this part here. Sorry, I'm going to use another color. Let's use orange. So this is S here, between the first point P and the second point P. So let's call this as S. Okay. Okay. So VP is equal to ds over dt, and we know S equals to R times theta from the sector punya equation lah. So this is called sector. You can go back and look at the sector punya apa ni video video explanation. This, I think you have learned this in maths before lah. So VP is equal to ds over dt, and S is equal to R times theta. So we can write this as D replacing R times theta, replacing S with R times theta over dt. Okay. All right. So now we know R is constant. R is not changing. So the constant component, you can then bring this outside. Bring the constant component outside in front. The theta here is not constant. This is variable. This is variable. This is always changing with respect to time. Okay. So what do we get from here? From here, we get VP is equal to R will come in front, R times. Now what we have here, because R has come in front, we will have d theta over dt. Okay. So now we have this equation VP is equal to R times d theta over dt. So what is d theta over dt? From the previous lesson, we know d theta over dt is basically omega. Okay, d theta over dt is omega, which is the angular velocity. So this is how the equation V equals to omega r was derived. So from here, we will finally get VP is equal to R d theta over dt has become omega. So therefore, Vp is equal to omega times the R lah, which is Rp slash O. Omega is the omega of the object lah. So this is how this equation was derived. So basically using the basic kinematics equation, V equals to ds over dt, and also the sector equation where we have S is equal to R times theta, and finally we can derive V is equal to omega times R for scala form, and we can also write down the vector form, which is V vector is equal to omega vector cross product R, right? So this is what we have been using in the class before lah. So V is equal to omega cross product R is the vector form of this equation. Okay. Now let's see another example before I move on to the next topic. In the previous class, we have done one example. So now let's look at another example of rotation. Okay, so you have an object, a rod here, OA. Given the angular velocity of OA is 10 radian per second clockwise. Okay, so angular velocity, we know that this is omega. Angular velocity is omega. So angular velocity of OA, which means that we write this as omega OA lah. We write this as omega OA, all right, is equal to 10 radian per second. This is the information that we have. Okay, and then we also know that it is clockwise direction. Determine the velocity of point A. So velocity of point A, what we want to calculate is basically VA. Okay, velocity of point A. So normally we want to calculate this in vector lah. So we want to know what is VA in vector. Okay, so first thing first, we need to know where is the direction of VA. So let's locate point A. Point A is here. Okay, so we want to know VA is pointing in which direction. So we know that this whole thing is rotating clockwise like this. Okay, so if you cannot imagine uh, the trajectory, so basically the trajectory of point A will be like this lah. A will make a circle around point O. So it is going to be a big circle with point O as the center. This is how A will travel, like this. Okay, point A. Okay, but if you cannot imagine that, let's draw the position vector first. Okay, the position vector always starts from the origin, which is now point O, and it is pointing towards A. So the position vector will be starting from O, pointing to A. Draw this, and this will be RA slash O. Okay, so once we have the position vector, now we can draw the velocity vector, which is 90 degrees to the position vector, 90 degrees. Okay, so since the rotation is clockwise, 90 degrees will be pointing to the right. So this will be the direction of VA. Okay, the direction of VA. Okay, so now we have the direction of VA. We have our position vector RA slash O. Now we can write down the equation. So our equation is VA vector is equal to omega OA, a vector, cross product RA slash O, also a vector. Okay, so we need to find what is RA slash O first. Okay, so RA/O, by looking at the figure here, we can already identify this is the height is 0.8 meter, and it is pointing upwards in y-axis. Okay, before that, you should draw your axis lah. So you should define your axis. X is positive, pointing to the right, and y is positive, pointing upwards. So RA/O will be in the positive direction of y-axis. Therefore, we write RA/O is equal to 0.8 positive, and in y-axis, which is J unit vector, and this is the unit is meter. Okay. Next, we write down the omega OA. Omega OA in vector. We know that the magnitude is 10, the value is 10, and we know it is rotating clockwise. So clockwise is negative. Okay, clockwise is negative, and anti-clockwise is positive. Okay, in rotation motion, we always take anti-clockwise as positive. Anti-clockwise is positive, and clockwise is negative. Okay, so since this is clockwise, it is going to be negative. The value is 10, and the rotation is always in the unit vector of z-axis, which is unit vector k. Okay, z-axis. So the unit is radian per second. Okay, we have x, y, and z. This is x-axis, which is unit vector of I. We have y-axis, which is unit vector of j, and we have the z-axis, the unit vector of k. Rotation always occur in the z-axis. Okay, so now we can proceed with the calculation. So VA is basically equals to minus 10K cross product 0.8 J. Okay, so how to solve the vector cross product? First, we multiply the value. Okay, we multiply the value. So the value here, you have minus 10, the value, and 0.8. So multiply these two will give you minus 8. Okay, will give you minus 8. And then now, we will do the cross product of the unit vector k cross product j. So how to do this? We do I, j, and k in the anti-clockwise manner. So I to j anti-clockwise, j to k anti-clockwise, and k to I anti-clockwise. So here we have k to j. So k going to j will be this in this direction, which is negative, and which will give you k cross j will give you I, will give you negative I. Okay, for the anti-clockwise, this will be positive, this will be positive, and this will be positive. But now we have k cross j, which is in the clockwise direction, will give you, so basically we have k cross j in clockwise will give you I, and the value will be negative because it is in clockwise direction. So here we have here negative I. That is the result of vector cross product k and j. So finally, therefore, the value of VA will be, you have two negatives here, so it will cancel out, will be equal to 8I, and the unit is meter per second. Okay, so if you look back at the initial direction of VA is pointing in the positive x-axis, and this corresponds to our answer. The answer here is positive in x-axis. So which means that the answer is correct. Okay, any question so far on this? Before we move on to the next part, which is the general plane motion. Any question? Okay, if there's no question, let's move on to the general plane motion. Wait, let me open the slide. Okay. Can you see the slide? Okay, this is the previous example. Okay, now let's move on to general plane motion. So general plane motion means uh, the motion involves both translation and also rotation. So this will be translation plus rotation. That is what general plane motion means. Okay, so if you look at this object here, this blue object, it starts from this position. Let's call this position number 1. And it has moved to this new position, position number 2. And you can see that the object not only translate, but it also has undergo rotation. Okay, so if we draw the position vector of 2 points on this object, we have point A and also point B. So point A will give you DRA. DRA means the change of position of point A lah. DRA. D is the change. RA is the position of A. Position from the position of A at object position number 1, and the position of A at position number 2. So that will be the change of RA, DRA. And we also have point B, which is DRB, okay, at first position and also the second position. We can also draw the position of B with respect to A, which is called RB slash A. And we also have RB slash A prime at position number 2. Okay. Now, let's visualize the motion. So first, the object undergoes translation. Let's repeat that. First, the object undergoes translation. Okay. In translation, we have learned about translation in the previous class. The displacement of every particles on the body, which is now we're talking about A and B, is the same. Okay, is the same, which means that on the top we have DRA, at the bottom we have DRB, which is also equivalent to DRA. So both is DRA lah, in this case, in the case of translation. And we also have the position of B with respect to A, RB slash A, which is also the same from position 1 until position 2 of the translation motion. Now, in the second phase of the motion, the object will undergo rotation. Now, the rotation happens about point A. Point A now becomes the origin, the fixed axis, and the object rotates about point A. So the one that is rotating, the one that is moving around point A is basically point B. Okay. So there is the omega angular velocity and also the angular acceleration alpha lah. Okay. So just for you to remember, counterclockwise or anti-clockwise rotation is always positive, like what we have discussed before, and also the clockwise rotation is always taken as negative. Okay, so now because the top position is the same as the bottom position, so we can bring DRA down there. Okay, and that will be RB slash A prime, the one that we did before. So here it will be the change of RB slash A, because initially we have RB slash A. When it has rotated, it becomes RB slash A prime. So the bottom part will be the change of RB slash A. So DRB slash A. D represents the change. Okay. And then we have here this component. Let's zoom in. Okay, we have here this component. Oops. Which is DRB. So starting from position 1, position 1 is here, is basically here. Let's call this position 1 prime, the intermediate position. It is undergoing translation, and position number 2 is after the body has rotated. Okay, so we have here DRA at the bottom because it is equal to the top A to A. And then we have the change of position of point B starting from here. This is point B going to here after rotation, and we call this as DRB slash A. And then we have the position of B, initial position of B, with respect to the final position of B. This is called DRB. Okay. So now we can write the equation. If you can extract the triangle here, in vector, we always work with triangle. So we have one pointing this way. We have another one pointing this way. And we have this one pointing in this direction. So this is basically DRA is here. DRA, right? Here is DRB slash A. And here is DRB. Okay. So from here, we can write the equation DRB is equal to the bottom one lah. DRA plus DRB slash A. Okay, this is what you get from this vector. Okay, from this vector. So the same like what is written here lah. Okay, so we can then differentiate this over time. Okay, we can differentiate this over time, which will give us the velocity. dr over dt or ds over dt is equal to v. Okay, remember v is equal to dr over dt or ds over dt lah. So from here we get this. Okay, drb over dt is equal to dra over dt plus drb slash a over dt. So this will give you, drb dt will give you vb, dra dt will give you va, and drb slash a dt will give you vb slash a. Okay. So this is basically the translation component. So remember, the object now undergoes two types of motion. The first phase is translation. The second phase is rotation. So that's why the component of velocity will also have two components. One is translation component and the other one is rotation component. Okay. Okay. So from here, VB is equal to VA plus VB slash A. So we know that the rotation component, now let's zoom in. This is the translation component. This is the translation component. This is the rotation component. VB slash A is the rotation component. And for rotation, we know the equation before that V is equal to omega cross product R. Okay, this is what we have learned before, vector. Okay, so therefore we can change this VB slash A, we can transform it into omega cross product R because VB slash A is the rotation component. Okay, so after we have transformed it, then we will get this equation. VB is equal to VA plus omega here is omega AB lah. Omega here is basically omega AB for this case, for this object, cross product RB slash A. So this is the equation to calculate velocity in general plane motion. GPM is the general plane motion. Okay, so what is the difference here? The difference here is that for rotation, we calculate V. Let's take this VA lah. VA is equal to omega OA, for example, cross product RA slash O. Okay, all these are vectors. And for GPM, general plane motion, the equation now becomes VB. For example, another point, VB is equal to VA plus omega AB cross product RB slash A. Okay, so you can see that the equation is slightly different. The one that is different is this part here lah. Ada satu extra component in front, which is the translation punya component. Okay, for rotation, we don't have that component in the equation. Okay, so now we have learned two types of equation. One is for rotation. V is equal to omega times R. That is for rotation. And for general plane motion, we have VB is equal to VA plus omega AB cross product RB slash A. Okay, so to understand better, let's look at some example problem. Okay, so let's go to here. Right, this is an example of a general plane motion problem. Okay, let's read the question. If the collar C, okay, where is the collar C? Collar C is here. This is collar C. Slides with linear velocity as shown. Okay, so basically, collar C is sliding. In which direction do you think collar C is sliding? To the right or to the left? Based on the figure here, based on the information that we have here, we should always look at the velocity direction. Acceleration doesn't actually tell you in which direction the object is moving, because acceleration can be accelerating forward. It also can be accelerating backwards. If you accelerate backward, it means that you are slowing down. A car moving forward can have a backwards deceleration, which means that the car is braking, is slowing down. So in this case, the collar C here is moving to the right. The collar C is moving to the right because the direction of velocity VC is pointing to the right. Okay. So what is the question here? Determine the angular velocity of rod BC. Okay, so let's highlight what we want to calculate. Angular velocity of rod BC. That is what we want. Okay, so angular velocity of rod BC, let's write it down. It will be omega BC. That is what we want. Okay, before we go there, let's identify the type of motion that we have here. So we have basically two objects. One is object AB, rod AB, and the other one is rod BC. Okay, if C is moving to the right, so let's draw velocity of C, which is pointing this way. VC is equal to 2 meter per second. Okay, if VC is pointing to the right, what is actually happening to the rod AB and BC? So basically, we will estimate that AB is rotating this way, right? And also BC is rotating this way too. Okay, so this will be omega AB, and this rotation will be omega BC. Okay, so this is the one that we want to find, omega BC. Omega BC is the one that we need to calculate. Okay, so how do we start? We always start from the origin. So now let's identify where the origin is. The origin is basically at point A here, because point A is the fixed point. Origin always start at the fixed point. So let's draw the first position vector. Okay, remember that is the reason why we learn position vector in the first class. We always start by calculating the position vector. Okay, so we have the origin A. So now we want position vector of point B with respect to the origin A. So let's draw from point A pointing to B. That will be our first position vector. How do we write this? This will be RB slash A. Okay, A is the origin. So that will be RB slash A. So how do we get the position vector? Let's make a triangle out of this. So you need to have one component to the left, which is X component. X component is pointing to the left and Y component is pointing upwards. This is the Y component. Okay. So we know the length of AB is 0.6. So the X component, this component will be 0.6. We know the angle is 60 degrees here. So this will be 0.6 cos 60 degrees, right? 0.6 cos 60 degrees. What do we get from 0.6 cos 60 degrees? I think it's 0.3. 0. Cos 60. 0.6. Yes, 0.3. This will be 0.3 meter. And then the other part will be 0.6 sine 60 degrees, which will be equal to sine 60 times 0.6 is 0.5196. Okay, 0.5196 meter. Okay, this unit is meter. All right. So now let's write this down in vector. So you have RB slash A vector is equal to, you see that the X component is pointing to the left, which is negative. Okay, so it is minus 0.3 I right? And then the y component is pointing upwards, which will be positive, so plus 0.5196 J in meter. Okay, so that is the position vector of RB slash A. Now, let's start with the rod AB first. So for rod AB, the type of motion will be rotation lah, because A is a fixed point. So you can imagine the rod AB or the point B will rotate about A. This will be the path of motion of point B. So point B will make a big circle about A like this. B will keep on rotating about point A. Okay, all right. So we know that the rod AB undergoes rotation. So we can first calculate VB first. So before we calculate VB, we need to draw the velocity vector of point B, velocity of point B. Okay, this is point B over here. So the velocity vector is tangent to the path of point B, or also 90 degrees to the position vector RB slash A. So 90 degrees will be pointing somewhere in this direction. Okay, this direction. This is VB. Okay, this is VB. 90 degrees to RB slash A. Okay, so now we can then calculate VB. VB is equal to omega AB. V is equal to omega cross R, remember? So VB is equal to omega AB cross product RB slash A. Okay. VB is equal to omega AB cross product RB slash A. Okay. Okay, so now omega AB is unknown. Okay, omega AB is unknown, is not given in the question. So RB slash A is already known. We know what is the value of RB slash A. So we can then write this as equal to omega AB. We need to convert this into unit vector. Although the value is unknown, you just write this as omega AB K. Omega AB K. Okay. Okay, just write omega ABK. We assume that the value is positive first. So you don't put negative omega ABK. Although we estimate that the rotation is anti-clockwise, which should be negative. But in the formula, in the calculation, you just put in omega ABK, assuming that it is positive. So we put in then cross product of RB slash A. So we can copy this and, sorry, we can copy this and put this here. Okay. Right? So put a bracket there. Okay. So how do we do cross product of multiple items like this? So the first thing, the same, you multiply the value. So now we have omega AB, which the value is unknown, and we have negative 0.3. So what do we get here is minus 0.3 times omega AB. So minus 0.3 omega AB. Okay. And then we have omega AB and 0.5196. Okay, so leave a space over there because we want to put the unit vector later. Now you can write 0.5196 0.5196 times omega AB. Okay, just multiply these two values. Okay, now next step is then to multiply the cross product of the unit vector. Now K cross product I. So we have I going to J in anti-clockwise, J going to K in anti-clockwise, and K going to I in anti-clockwise. This will give you positive, positive, positive. Okay, so now what we have? We have K going to I, which will give you J. Okay, K going to I in anti-clockwise which will give you J, and J value is positive because it is anti-clockwise. So now we have times positive J. This is our first value. And then the next one is K. The next one is then K cross product with J. Okay, so what do we have now? We have now K going to J in the anti-clockwise direction, which will give you negative I because it is anti-clockwise. So here is negative I. Negative will come in front. So I will be placed here. Okay. So finally, we can write VB is equal to, you can bring I in front. So minus 0.5196 omega AB, which is unknown, still unknown. Later we will solve it. I and minus 0.3 omega AB J. Okay. Okay. So this is what we have so far. Okay. Next, we need to go to the second rod, which is the second rod is rod BC. Okay, second rod is rod BC. Okay, this rod. We have previously calculated for rod AB, but we cannot solve because we are stuck with VB equals to something omega AB I and omega AB J. We don't know what is the value of omega AB. Later we can solve it. Okay, so now let's move on to the second object, which is object BC or rod BC. So we follow the this AB direction. So AB is pointing upwards. So next we will start with point B pointing to C. Okay, pointing to C. This will be your position vector, next position vector, which is RC/B. Okay, because B is now the reference point. Okay, so to solve this, we do the same. We need to get a triangle. So you have one triangle going up like that in y-axis, and another triangle is going to the right in x-axis. And what is this angle here? This angle is basically 45 degrees because it is already given here, 45 degrees. So it should be also the same over there, 45 degrees as well. Okay, so we know the length BC is 0.4. So now what you need to calculate is 0.4 cos 45 and also 0.4 sine 45, which will give you the same value lah. So cos 45 degrees times 0.4, which will give us 0.2828. So here will be 0.2828. Up here will also give you 0.282828. Okay, this is basically 0.4 cos 45 degrees. Okay, up there is 0.4 sine 45, which will give you the same value. Okay, so now we can write down RC/B. Okay, RC/B vector is equal to both are positive. Okay, you can see y-axis is positive pointing upwards and also x-axis is positive pointing to the right. So we have 0.2828i, okay, and plus 0.2828j. Unit is in meter. That is RC/B. Okay. Now come the part that we just learned before, which is the formula for general plane motion. Okay, now what we want to write down is now VC. Okay, VC is equal to, okay, look at this figure here. You have point C here and you have point B here. Okay, so in this object that is undergoing general plane motion, why is this general plane motion? Because point C is moving left and right, which is translation. Point B is moving in a circle, so this is rotation. Okay, so you have both rotation here and translation up here. Therefore, this rod BC is undergoing general plane motion. Okay, so for general plane motion, we have learned the equation before. VC is equal to, you need to look at the object, the rod BC. So another point will be point B. So you need to write VC equal to VB plus now omega of the object lah, the rod, which is now omega BC, also a vector, and cross product RC/B. Okay, this is the one that we have just calculated. Okay. So now VC, we do know the value of VC, which is given 2 meter per second to the right. So we also need to write this in unit vector form. So what you do is VC will be equal to 2I. Okay, because it is 2 meter per second to the right, which is positive. So VC equals to 2I equal to VB. We will take this value that we have calculated before, which is 0.5196 omega ABI and minus 0.3 omega ABJ. So this is basically VB. So let's put this in bracket. Okay, this is VB. Okay, and then plus omega BC is also unknown. So plus, we write down omega BC times K. Okay, K is the unit vector lah for rotation. And then cross product RC/B. RC/B we have calculated up here. So we can just copy this and paste it here. Okay, let's resize it a bit and put it here. Okay, I need to move this a little bit to here. Okay. And let's take this. Put there. Okay. So this also we put it in bracket. Okay. So this is the final equation that we have. VC is equal to 2I because VC is already given. VC is 2 meter per second in x-axis to the right. So that's why it is 2I positive. VB we have calculated before, but we don't know what is the value of omega AB. So we have an unknown here. And then omega BC is also unknown. So you write down omega BC K because the value is still unknown. And RC/B we have calculated here. So we just take that value and put it here. Okay. So first thing first is to calculate this part, because this involves vector cross product. The rest does not have vector cross product. So you need to settle the vector cross product first. So let's go to this part. Okay. The same process, you multiply omega BC and the value. So what we have here is 0.2828 times omega BC. Okay. And then we have K cross I. So you write down again, I to J in anti-clockwise direction, J to K in anti-clockwise, and also K to I. So what do we have here is K cross product I, which will give you positive J. Okay, which will give you positive J. So here is multiply with J. Okay, that is the first part. The second part is omega BC and 0.2828. So let's write that down. 0.2828 omega BC. Okay. And then now we have K cross J. So K cross J will be going in this direction, which is negative, and will give you I. Okay. So here we have negative in front and I at the back. Okay. So this is what we have from the vector multiplication. Okay, so let's take this to the next page so that we can continue how to solve this. Okay, I will copy all this. Okay. And paste it here. Okay, so this is what we have before. Okay, so basically we can erase this part because we have already calculated, and this will become plus here, and this we can take this up there. Okay. So how do we solve this? All right. So when we come to this stage of calculation, what we need to do now is basically to separate this equation in I and J component. So let's do I component here, put a double dot there, and also J component here, put a double dot there. Okay, let's take the right-hand side of the equation first. So for I component, you take minus 0.5196 omega AB. Okay, do not write I because we already taken I there. And for the omega BC, it's minus 0.2828 omega BC. Okay. And then equal to, look at the left-hand side of the equation, you have 2I. So write down 2. Okay. Now for J component, we have for omega AB is negative 0.3 omega AB. Right? For omega BC, we have plus 0.2828 omega BC equal to, look at the left-hand side of the equation, there's nothing in J component. So therefore you write down 0. Okay, so this is where we need to solve simultaneous equation. Okay, solve simultaneous equation. Okay. I hope you know how to use your calculator to solve simultaneous equation. Later, I will show in the class. Next week, Monday, we have a face-to-face class. So I will show on in the class next week how to use your calculator to solve simultaneous equation. For now, you can try to Google it, how to use the simultaneous, how to solve simultaneous equation using your calculator. So let's try to solve this. 0.5196 omega AB minus 0.2828 omega BC is equal to 2. That is our first equation. The second equation is minus 0.3 omega AB plus 0.2828 omega BC is equal to 0. And let's try to solve this. Okay, let's see what is the value. Okay, so we have omega AB. Oops, sorry. We have omega AB is equal to minus 2.4407. Unit is radian per second. Okay. And then omega BC is minus 2.589. Unit is also radian per second. So basically, we have solved the question here, because the question wants us to calculate omega BC. So this is basically omega BC. And you can see that both answer have negative value. Okay, so which means that our earlier prediction, if you look here, we predicted that omega AB is rotating clockwise, which is negative. So the answer is correct. And omega BC is also rotating clockwise, and we also get a negative answer. So both answer should be correct based on our earlier estimation lah. Okay, so I think that is the example that I would like to show today. Do you have any question on this? Any question on the general plane motion? So now the calculation has become a little bit more complicated. Not only we focus on the rotation component like what we did before. Rotation is only involve one object. Okay, one object is rotating. But now there is another connecting object. One object is rotating and the other object or rod is connected to it. And because of the rotation of the bottom object, bottom rod, the top object will have general plane motion. And therefore, we need to do this calculation to get what is the value of, depending on the question lah. Sometimes you are asked to calculate the velocity of the point. In this case, we have 3 points. Okay, you need to understand the point and the body, the rod. So point here, we have point A, which is fixed point. We have point B, connecting point, and we have point C. So these are points. Points will have linear velocity. But in this case, we have two bodies or two rods. Rods AB and also rod BC. So the rod will have angular velocity, which is omega. Point does not have omega. Point belongs to the body, the rigid body lah. The rigid body is AB. In the rigid body AB, you have 2 points, which is point A and also point B. So points have velocity and the body has angular velocity. So that is the difference lah. Okay, any question before we end the class today? I will share the recording of this class in the WhatsApp group, as well as I will upload also in Kalam for your reference. So if you have, if you miss a few part, you can always go back and watch. If you do not understand, you can watch again. And in the next class on Monday, we will continue doing a few more tutorial questions so that you can understand better on the calculation of general plane motion. Okay, any question before we end the class? All clear? Okay, so
Clear.
all right, okay. So if there's no question, thank you for joining the class. I will save this recording and share to you in the WhatsApp group. Okay, thank you.
Thank you.
I will see you again next week, Monday, face to face. And that's all for today. Thank you.
Thank you,
Okay,
Doctor.
thank you, sir.
Right.
Thank you, sir.
Thank you, sir.
Thank you, sir.